All right, I just started the recording. Good evening once again, children.
Good evening, ma'am.
Yeah. Kindly tell me if we started, the questions from this presentation. See the first one. I think we started. I started this in the last class. We finished this. Yeah, I remember we also finished this. Should we continue from here, children? Just let me know. Look into your book and let me know.
Ma'am, I cannot see your screen.
Yes, ma'am, you are visible.
Oh my God. Is it visible now?
Yes, ma'am.
No, I forgot to
Yes,
share it.
ma'am.
Yeah. No, I hadn't shared my screen. I just started. Yeah. Yes, children, I just let me know. This is over, right?
Yes, ma'am.
What about this?
Yes, ma'am.
This one?
Over, ma'am.
This one?
It's done, ma'am.
Oh. This one?
Not yet, ma'am.
All right, yeah. All right, children. So write down this question. Use factor theorem to verify that x plus a is a factor of x to the power n plus a to the power n for any odd positive integer n. Oh, I think we finished this also because I remember that n was missing. Okay, let's anyways do this again. So now we have this polynomial x to the power n plus a to the power n. We have this polynomial x to the power n plus a to the power n. And what is n? N is any odd number. N is any odd number. Odd positive integer. Positive integer. Positive integer meaning 1, 2, 3, 4, 5, 6, and so on. Integer. Positive integer. 1 to plus 1 plus 2 plus 3 plus 4 and so on. Odd positive integer. So 1, 3 plus 1 plus 3 plus 5 plus 7 plus 9 and so on. Odd positive integer meaning odd numbers. So n is any odd number. So the expression can be x cubed plus a cubed, or it can be x to the power 5 plus a to the power 5, or it can be x to the power 17 plus a to the power 17, or it can be x to the power 33 plus a to the power 33. N stands for an odd number. N stands for an odd number. So this expression x to the power n, this expression x to the power n plus a to the power n, where n is any odd number. Odd number. Okay. Okay, so this is given to you. For this expression, you should prove that x plus a is always a factor. You must prove that x plus a is always a factor of x to the power n plus a to the power n. We'll have to prove that x plus a is always a factor of an expression like x to the power n plus a to the power n, where n is any odd number. So to prove that x plus a is a factor of x to the power n plus a to the power n, we simply have to use the factor theorem and show that the remainder is 0. If on dividing, not using the long division, so we have a procedure, you know that. So if using that procedure, you're able to, if using the theorem, you're able to show that the remainder is 0. Then x plus a is a factor of x to the power n plus a to the power n. So let's see how to do that. So see here. Look at the screen, children. So let f of x, we'll first name this polynomial. Let f of x be equal to x to the power n plus a to the power n. Let's name it, okay? Fine. Now, x plus a is the expression given. We have to show that x plus a is a factor of this one. So equate it to 0. X plus a is equal to 0. X is equal to minus a. Now we have to find f of minus a. And when you find f of minus a, you must get it is equal to 0. You must find f of minus a and you must get it as 0, which means x plus a is a factor of x to the power n plus a to the power n. All right, so we'll have to find f of minus a. And how do you find f of minus a? In f of x, wherever there is x, you should use minus a. In f of x, who's f of x? This one. In this one, wherever there is x, so there is x here. There's x here, there's x here. You should use minus a. You should use minus a. Here also minus a. So that is what is f of minus a. So f of minus a is equal to, see here for this x, you should say minus a to the power n plus a to the power n. A is a only. Only for x you must say minus a. A is a only. A cannot be written as minus a. Where there is x, use minus a. All right. Now, what you do? You write minus a as minus 1 into a. We all know that a into minus 1 is minus a. A into minus 1 is minus a. So do that. Minus a can be written as minus 1 into a. This power n as it is plus a to the power n as it is. Now we know that if we have something like 3 into 5, the whole power 2, this can be written as 3 to the power 2 into 5 to the power 2. AB, the whole power m, is equal to a to the power m into b to the power m. If the base, that is whatever is the power, it should be used for every term in the base. So if it is like ABC, the whole power 4, this is nothing but a to the power 4, b to the power 4, c to the power 4. But if it is ABC power 4 like this, then the power 4 is only for c, it is not for a and b. ABC to the power 4. This power 4 is only for C. It's not for A and B. This is different. ABC bracket and 4 means this one. Means A power 4, B power 4, C power 4. So similarly here, minus A to the power n. Minus A we write it as minus 1 into A, the whole power n. So this power n is for both minus 1 and a. So in the next step, minus 1 to the power n into a to the power n plus a to the power n. See it? Minus 1 to the power n into a to the power n plus a to the power n. Now you can take out a to the power n common. A power n is common. See here, this is see the separator is the plus sign. So these are the two expressions on either sides of the plus sign. On either sides of the plus and minus are the separators. Plus and minus sign are the separators in an expression. So this is the separator plus, and before the plus sign we have this expression, and after that we have this one. So in these two expressions, a to the power n is common. So take out a to the power n, common. Now a to the power n into this one will give you the first term. We have this one common here. So you should write this in the bracket. You must write this in the bracket. Now see, if you have AB plus A, what will you do? You will take out A common and then you will write B plus 1. Same thing we are doing. Same thing. Similarly, this one is common here. So you must write this in the bracket. Plus, and this is outside common. So 1. So 1. Then now it's easy to evaluate the value of minus 1 to the power n. It's very easy to find its value because we know that n is an odd number. N is an odd number. That means, and you know, 1 raised to any power is 1 only. 1 to the power 5 is 1. 1 to the power 10 is also 1. So when the power is odd, that means minus will happen odd number of times. So when you have odd number of minus signs, when you multiply them, you will get a minus. So when there are 3, when you'll have to multiply 3 minus signs like this, minus into minus plus, plus into minus minus. When you have 5, 1, 2, 3, 4, 5, you have to multiply 5 some minus signs, you know, 1, 2, 3, 4, 5. So this makes a plus. These two make a plus, plus into plus, plus, and with minus is minus. So the power is clearly odd because n is odd. The power is odd. So when the power is odd and the base is -1, the result is 1. Is it a +1 or a -1? That is the question. The answer is 1. But is it a +1 or a -1? It's a -1 because the power is odd. So there'll be odd number of minus signs. And when you multiply them, the final result will be negative. So -1. So -1 to the power n is -1. So in the next step, write this as it is. And we know we found the value of -1 to the power n. It will always be -1. It will always be -1. It's not that we are removing the power n. We have found the value of -1 to the power n. We are not taking out this power in the next step. No, we have evaluated this. We have evaluated this. We know that this one is always going to be -1 because the power is odd. N is odd. So always, you see, -1 to the power 99 is a -1. Because 99 minus signs have to be multiplied. It is minus. And 1 into 1 into 1 into 1, 99 times is 1 only. So -1. So we have evaluated this. This is always going to be -1. Don't think that we just took out the n in the next step. No, we evaluate this and the value is -1. So that's what is in the next step, -1, and this +1 as it is. Now -1 plus 1 is 0. And we have a to the power n into 0, which is 0. So what is that? We've been working. What have we been doing all the while? We've been working f of -a, and we've got f of -a is 0. F of -a is 0. The remainder is 0, which means x plus a is a factor of f of x. That's what you'll have to prove. Prove that x plus a is a factor. To prove it's a factor, the remainder should be 0. So we have got f of -a is 0. This clearly means that x plus a is a factor of f of x. That is a factor of x to the power n plus a to the power n. So see here, this means that f of x is exactly divisible by, because the remainder is 0, it's exactly divisible by x plus a. So therefore, x plus a is a factor of f of x for any odd positive integer n. I hope you are all listening carefully, children.
Yes, ma'am.
Yes. Yes, ma'am.
Yes, ma'am.
Very good, children. Just look into your notebook if you have already written this. Because it was important. I know we have finished this, but I wanted to repeat it because it's very important. Have we written it already?
We wrote it, ma'am. We finished till 8 questions.
Okay. This also we finished, is it, Madhumita?
Yes, ma'am.
Okay, then we'll have to continue from here.
Yes, ma'am.
All right. So here we have to prove that a cube plus b cube plus c cube minus 3abc is equal to half of a plus b plus c into a minus b the whole square plus b minus c the whole square plus c minus a the whole square. All right. Don't write down. Please listen first. So now we'll have to take up the left hand side and prove that it's equal to the, that is when you take up the LHS and work it, you must get this RHS as the answer. You prove that. You'll have to prove that this one is equal to this one. That means take up the LHS, work the LHS. Upon working the LHS, you must arrive at the RHS. So the LHS is equal to the RHS, hence proved. It's like that. So now this is the left hand side, a cube plus b cube plus c cube minus 3abc. What is the identity? What is this? It is a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ca. This is the identity. So this first step is simply the identity. And why are we writing that? Because that's what we have in the LHS here. We take up the LHS and we complete that. LHS is equal to, this is the identity, a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. That's the identity. Now in the next step. Now since the RHS has a half here, the RHS is a half here. So what we do, now tell me what is half into 2, children? What is half into 2? What is half into 1?
1, ma'am.
Because the product of a number and its reciprocal is always 1. The product of a number and its reciprocal is always 1. So half and its reciprocal 2. The product is 1. So supposing you have, say, some number like this, you multiply this by 1 by 5, and then you multiply by 5. What's the answer?
995 into 1, ma'am. 995.
It's the same. It's the same number because 5 and 5 gets cancelled. So it's like you're multiplying by 1. It's like you're multiplying by 1. When you multiply by a number and its reciprocal, that means you're multiplying by 1. So there is no change. That's what we're going to do here. What we're going to do is we're going to multiply by half and 2. So it's like this here, 2 and 2 gets cancelled. So you're not changing the value of the expression. When you multiply by 1, you're not changing the value of the expression. If you're adding 1, you're changing it. If you add 1 or subtract 1, you are changing the value of the expression. You're multiplying it by 1. You'll get the same answer. 5 into 1 is 5. So what we do is we write, see here, half into a plus b plus c into 2 into this bracket. So what is the net effect? 2, you're multiplying by half and 2. So see here, half and 2, half and 2. So it's like 2 and 2 gets cancelled. You're multiplying by 1. See, it's a product here. This is half into and into 2. We are multiplying by half and 2. When you do that, it's like you're multiplying by 1. 2 and 2 gets cancelled. So you're multiplying by 1. Okay. So half into a plus b plus c. So you're multiplying by half. Then in the second part, into 2, you're multiplying by 2, and then you're writing this as it is. So it's like you're multiplying by 1. So you're not changing the value of the expression. That is the next step. Now you write this half of a plus b plus c as it is and multiply the 2 with every term inside the bracket. So that gives you 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2c. Multiply 2 with every term inside the bracket. Now break it up. What is 2a square plus a square? What is 2b square plus b square? 2c square is c square plus c square. And write these 2ab terms as they are. That's the next step. After that, this is the next step. See, we finished till here. After that, we have the middle terms, minus 2ab, minus 2bc, minus 2ca. These are the middle terms. See here, minus 2ab. The first part comes as it is, children. This first part comes as it is. Now here in the second part, minus 2ab, minus 2bc, minus 2ca. See, minus 2bc, minus 2ca. Now for minus 2ab, we need an a square and b square. Because minus 2ab, so you need an a square and b square. For bc, we need b square and c square. And for c square, we need, for ca, we need c square and a square. So see here, we have 2 a squares, 2 b, we have 2 a squares, 2 b squares, and 2 c squares. So what we do, we write one a square here and one a square here. See here, one b square here and here, c square here and here. So we make use of them in the appropriate places. Where there is 2ab, we use one a square and one b square. So one a square and one b square. Where there is minus 2bc, we make use of one b square and one c square. So one b square and one c square is gone. And where there is 2ca, c and a, we make use of one c square and one a square. C square and a square. So see, we have made use of everything. And the middle terms, minus 2ab, minus 2bc, minus 2c. That's the next step. We gather them. So actually there are 9 terms here. There are 9 terms. So we group them like this in threes. According, not in any triples, in triples like this. All right. So that's the next step. So you enclose these 3 terms in a bracket plus these 3 terms in a bracket plus these 3 terms in a bracket. Now in the next, see, the first part comes as it is, children. This one is as it is till the last step. Now this one is nothing but a minus b the whole square. And this is nothing but b minus c the whole square. This is nothing but c minus a the whole square. Hence proved. You can see that we took up the left hand side and we worked, and we got something which is just the RHS here. Hence proved. Please take down, children. Please write down. Let me know once you finish.
Ma'am?
Yeah.
Ma'am, I have a doubt, ma'am.
Please ask me.
I'm on second step, no ma'am. That half a plus b the whole and the 2a square to 2b square, no ma'am. We can take the 2 as a common, no ma'am.
Hmm.
And we can cancel half and 2, no ma'am.
You want to cancel half and 2, is it?
Yes, ma'am.
Can you just think and see if you can help yourself? What have we done in the next step? We have multiplied by half and 2. And if you cancel it, you'll get back the first step. We have done, why did we see after writing the identity? This is the identity. A cube plus b cube plus c cube minus 3abc is this one. This is the identity. In the next step, we multiply by half and 2. And we know that the product of half and 2 is nothing but 1. So you can definitely do this because the product is 1 and you're multiplying by 1. So we multiply this first part by half and the second part by 2. And the second part by 2. And we retain this half of a plus b plus c as it is, because that's what you need here. And use 2 with every term inside the bracket. Now, if you cancel that, you'll go back to the first step. We multiply by half and 2 in order to get this result. So after doing that, you cannot again cancel. Then you'll go back to this step. You need to retain half. You can see the answer here. You can see the result here. You need to retain this one. If you do this, then that half will go away. Then you will not get the desired result. Okay, you're not convinced, Tanishka?
No, ma'am, understood, ma'am.
Okay. Please write down, children. This is from NCRT.
Completed, ma'am.
All right. Done, all of you?
Ma'am, 2 minutes, ma'am. Last few steps.
All right.
Completed, ma'am.
Yeah. Class? Done?
Completed, ma'am.
All right.
Completed, ma'am.
All right, children. Let's go to the next one. Raja, you writing?
No, ma'am.
Yes or no?
No, ma'am.
May I know why?
No, ma'am. I'm telling I completed.
Oh, oh, you meant that. Okay. All right. All right, children. This is the next one. Please write down. This is the next one. Done, children? Yeah. It may be a lengthy proof, but it's very simple. Just listen carefully. All right. So children, take up the LHS. You need to prove that this one is equal to what you see here. So take up the LHS. LHS is a plus b plus c the whole cubed minus a cubed minus b cubed minus c cubed. Okay, take up that. Now, you can group this in any way. I have grouped b plus c. You can try grouping a plus b and a plus c also. You will get the same result. So I have grouped using b plus c. So what I do is, because I don't know how to expand a plus b plus c the whole cubed. I don't know how to expand this. I know, or we can expand when we have two terms. We know how to cube a binomial. We know how to cube a binomial and not a trinomial. All right, so like we know what is x plus y the whole cubed. We know this. We know what is x plus y the whole cubed. Is x cubed plus y cubed plus 3 x square y plus 3x y square. We know that. So this is a binomial, two terms. This is the cube of a binomial. Two terms, x plus y, two terms, binomial. Binomial, cube. So when there are two terms, so we know how to cube a binomial, but we don't know how to cube a trinomial. A plus b plus c, the whole square we know. We know how to square a trinomial. A square plus, what is a plus b plus c the whole square? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. So we know how to square a trinomial. A plus b plus c the whole square we know. But a plus b plus c the whole cubed, no, we don't have a formula for that. See, when I say we don't have a formula, I'm talking with regard to our syllabus. Okay, with regard to our syllabus. Okay, so we don't know how to cube a trinomial. So we convert that to a binomial. So we convert that to a binomial because we know how to cube a binomial. Two terms, we know how to cube it. We know the formula. That is why we do this. That's exactly why we do this. So what we do, we enclose b plus c in a bracket. Like we look at this as one term now. B plus c is one term. Like this is x, this is y, the whole cubed. See this one, we are taking this one as x and this one as y. Okay, the whole cubed. That's why we put a bracket for b plus c. So that's the next step. That's all, nothing else. 1 minute, children. This is x. This is y. So that's what we're doing here. So we put this a in a bracket. This one is stands alone plus this full thing is y. This is x and this full thing is y. So put that in a bracket, whole cubed. Now what you do is you have grouped b and c here. You have grouped b and c here. So here also you should put a bracket for b cubed and c cubed. So you cannot simply put a bracket here like this. You will change the meaning. So what should you do? When you put a bracket here, it should still be minus b cubed minus c cubed. So see here, this minus a cubed as it is, this minus is common. So open bracket, minus into b cubed is minus b cubed. Minus into plus is minus c cubed. So be careful with the signs. Be careful with the signs. I have grouped b plus c here. So here also I'm going to do the same thing. I'm going to write minus a cubed separately like this and going to group these two. So write this minus sign and open a bracket. Minus into b cubed is minus b cubed. Minus into plus is minus and c cubed. So what did I say? Since we know x plus y, the formula for x plus y, the whole cubed, there should be only two terms. So here we enclose a bracket for b plus c. So this becomes the y term and this is the x term. So now there are two terms, the whole cube. So we know we have a formula, we know how to expand it. So since b and c is in a bracket here also we put b and c in a bracket. For that what we do, we write this minus a cubed as it is. And here this minus, meaning that's not common, like we write this minus outside, whatever is the sign here, put that outside, open a bracket, minus into b cubed is minus b cubed, minus into plus is minus and c cubed. So this is the second step. This is the second step, enclosing brackets. the second step. So here also for b plus c we put a bracket. Here also for b and c we put a bracket. That's the second step. Now the next step is to just expand. How do you expand? How do you expand? See here, this is like x plus y the whole cube. So see here, x cubed plus 3x square y. Please see this, 3x square y plus 3xy square plus y cubed. What is x, children? What is x? A. And what is y? B plus c. Okay, and what is x plus y the whole cubed? X plus y the whole cubed is x cubed plus 3x square y plus 3xy square plus y cubed, wherein your x is a and your y is b plus c. That's what is here. See here. Understand this yourself? These four terms. This is only your x cubed. This is your 3x square y. This is your 3xy square. And this is your y cubed. I think I marked it on the next step. All right, children. I should have marked it here. This step is what we're doing here. X cubed 3x square y 3xy square plus y cubed. All right. Now here continue whatever. Now this is what we have expanded the first bracket, right? This minus a cubed as it is, and here minus what is b cubed plus c cubed? What is x cubed plus y cubed? It's x plus y into x square minus xy plus y square plus y square. This is what is x cubed plus y cubed. X cubed plus y cubed is equal to x plus y of x square minus xy plus y square. Okay, so b cubed plus c cubed is b plus c into b square minus bc plus c square. This minus a cubed as it is. So please understand what happens in the second step. So first step is about brackets. The second step is about expanding using the formula. So here x cubed 3x square y 3xy square and y cubed. And this minus a cubed as it is. And then this b cubed plus c cubed is the formula, that minus as it is outside. And this is the formula again. That's the next step. Now, Raja, please complete the formula. What is x plus y the whole cubed, Raja? Who can tell me what is x plus y the whole cubed?
Ma'am, can I?
Yeah, please tell me.
Ma'am, it's x cubed plus 3x square y plus 3xy square plus y cubed, ma'am.
Very good. Thank you, Madhumita. Very good. And Tanishka, what is x cubed plus y cubed? Danya?
Ma'am, it's x plus y, x square minus xy plus y square, ma'am.
Very good. Thank you. All right. So these are the identities used and for the second step here. Now in the next step, we'll just work it out. So this is a cubed. Remove the bracket and all that. So this is a cube. This one will be 3a square into b plus c. This one will be the same thing, 3a into b plus c the whole square, b plus c the whole cubed as it is. And here minus a cubed, nothing in this. I've just shown the steps here. You can write the steps straight away. I've just here now, I've just put bracket like x the whole cube plus 3x square into y. So in the next step, I've not done anything much. I've just removed the brackets and see here, a cubed 3a square into b plus c. Please watch this. Nothing much in the next step. Nothing much in the next step. In the next step, what happens is this plus a cubed and minus a cubed gets cancelled. Plus a cubed minus a cubed plus gets cancelled. So that's what I've written. In the next step, nothing much I've done. Then I've written the remaining terms. I've just cancelled this a cubed and minus a cubed in the next step. I've written the remaining terms. You can see this one here. 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 Nothing much in the next step. I've just written the remaining terms. Now in the next step, you can see that b plus c is common everywhere. See here, this is one term. This is one term. This is one term. And this is one term. How do you know the terms? They're separated by a plus or minus sign. See here. See here. Separators. These are the separators. Okay, there are two plus signs and one minus sign. So there are four terms and all. Now you can see everywhere. You can see everywhere b plus c is common. So here if you take, if this b plus c comes out common b plus c, this 3a square you should write inside the bracket. This 3a square will come inside the bracket. Then this plus sign plus. This is b plus c the whole square. 1b plus c is common outside. So what will come in the bracket? 3a into b plus c, because b plus c the whole square it is. So 1b plus c will come. 3a and b plus c. And the next term is b plus c the whole cubed. So there is one b plus c outside. So 2b plus c is inside the bracket, b plus c the whole square. Minus b plus c is outside common. So this one will come as it is. This one will come inside. That's about the next step. Taking b plus c common. Taking b plus c common. Okay, the next step, nothing. I've just done one extra thing. You can, nothing else you can do. You can only square this in the next step. You can only square this in the next step. So I've written this 3a square as it is. This one as it is. This b plus c the whole square is this one. A plus b the whole square. So b plus c the whole square. B square 2bc c square. And this one as it is. That's the next step. A few steps. If you understand the proof well, few steps you can omit. So because it's important, I've just I think shown a few steps extra. So nothing much in the next step. So I've just expanded this one. That's all in the next step. Now you can open the brackets here. You can open the brackets here. Now this part alone, you can open the brackets. So what will come? This b plus c as it is. This one as it is. This one as it is. Here open the bracket. So b square 2bc c square minus b square plus bc minus c square. You can see that here. That is what you're doing in the next step is you're simplifying this one alone. You're simplifying this one alone. So we have opened the brackets. Now what happens? B square minus b square. C square minus c square. So 2bc plus bc is 3bc. 3bc. So you should write this one. You must write this one. You must write this one. And here you have 2bc plus bc, just 3bc. That is the next step. That is the next step. Now again in the bracket, in the second part in the bracket, 3 is common. Here, there's 3 here, there's 3 here, there is 3 here. So take out 3 common. Take out 3 common. So when you bring out 3c, you can see the 3 here, 3 common. This b plus c will come as it is. So there'll be only a square and there'll be only a into b plus c and there'll be bc. Because 3 has come out. So remove the 3's and write the remaining things inside the bracket. Take away the 3's. Don't write. Sorry. Take away the 3's, this 3 and this 3, don't write this. So a square, a into b plus c and bc as it is inside the bracket. That is the next step. Now in the bracket, inside the second bracket, remove everything, meaning remove the brackets inside the second bracket. So a into b is ab, a into c is ac. So a square, ab, ac and bc. Open up the bracket in the second bracket. This 3 into b plus c as it is. Here this a square, this bc. A into b is ab and a into c is ac. Now we have 4 terms. We have learned in standard 8. When there are 4 terms, you can factorize by grouping. You can change the order also if needed. You can factorize by grouping. So here you can group the first 2 terms and the last 2 terms. So in the first 2 terms, a is common. A into a is a square, a into b is ab. Then the last 2 terms, c is common. C into a is ac, c into b is bc. So you can see we have a plus b inside the bracket. See here, in standard 8, we have a question like this, factorize. They'll give you an expression like this and they'll say factorize. See this expression alone. This one alone we have done in 8th standard. So we group the first 2 terms and the last 2 terms. A is common, so a plus b. Then last two terms C is common, so A plus B. Now A plus B is again common in the two parts. So we write A plus B once and the other bracket A plus C. So you all know this. That's what is here. This 3 into B plus C. And then this one on factorizing, we get A plus B into A plus C. A plus B into A plus B. Then finally, just rearrange. So write 3, A plus B first, B plus C, and C plus C, which is the RHS. You can see the RHS. Hence proved. So I'll just I'll give you meaning, understand, and then write down, children. See, what we are doing is in the first step, we're just putting a bracket here. And since B plus C, we have put in a bracket here also, we're putting B cubed and C cubed in a bracket. That's the first step. Now, when you're practicing, do with B plus C only. Then once you understand, you can group the others. If you put a bracket for A plus B here, if you put a bracket for A plus B here, you should put a bracket for A plus B here also. So that you can try later. Now you don't do all that now. First you practice this one. Okay, so the first step is to enclose B plus C in a bracket and this B cubed and C cubed in a bracket. That's the first step. So that's what we have done here. Then we expand this using the identity x plus y the whole cube. That's what we see here. And here this B cube plus C cube, we again use the identity B plus C, B square minus BC plus C square. Two identities we use and we get this step and this step. After that, what happens? So after that, what happens is this A cubed and minus A cubed gets cancelled. And then we write the remaining terms. These are the remaining terms. And in the remaining terms, you can see that B plus C is common. So we'll bring out B plus C common and we have all this inside the bracket. And then what we do, we square the B plus C the whole square. We expand that. We expand that. We expand that, and later what we do is we simplify the last two brackets. The last two brackets, we won't disturb 3a square and 3a into b plus c. The last two parts we'll simplify. So we open the bracket and we cancel and all that, and we get 3bc. Then of the terms here, 3 again is common, so we bring out 3 common. This 3 is common, 3 is common, so we bring out 3. And that's how we get these terms in the bracket. Now we open this AB, AC. Now we have 4 terms and we factorize by grouping. Factorize by grouping and this one, and then we just rearrange RHS. Yes, children, please write down. I'll just come back in some time. I'll give you, I think, 5 or 10 minutes for this. Go through once and then write down. Write down and then you can mark your dots. If you have any questions, you can ask me. Just write the identity. Yeah, please start writing, children. I'll just write the identities used here. X plus y the whole cube. These are the identities used here. X plus y the whole cube is x cube plus 3x square y plus 3xy square plus y cubed. And we have also used x cubed plus y cubed. X plus y into x square minus xy plus y squared. Yeah. Yes, children, please start writing.
Completed, ma'am.
Okay, so Tanishka, right? Completed?
Yes, ma'am.
All right. What about Tanishka's friends? Done?
Completed, ma'am.
Yeah, now you must ask me your questions, children. Any part not clear? See, first thing is you need to practice. Now, you understood meaning? Do you understand every line, like how you get the next lines? Any doubt, questions?
No, ma'am, it's clear.
Okay. All right. Yeah, I think this is the last one. We have one more. Okay, we have two more. Yes, children. Please write down. All right. Fine. So here you can see that this is a direct one. So you can see that this is like, x cubed plus y cubed plus z cubed minus 3x y z. See, x y z x y z. See that? X is a plus b, y is b plus c, and z is c plus a. X cubed plus y cubed plus z cubed minus 3x a plus b, y b plus c, z c plus a. So what you see in the left hand side, what you see in the left hand side is of the form x cubed plus y cubed plus z cubed minus 3x y z. And what is it? What is x cubed plus y cubed plus z cubed minus 3xyz? X plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus xz. That's the identity. So we'll use identity. So where I told you x is this, y is this, and z is this. So x cubed. So we take up the LHS. We take up the left hand side. This is what is given in the left hand side. This is what is given in the left hand side. So x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z. See, this is x plus y plus z. See here, x plus y plus z into x square plus y square plus z square. X square plus y square plus z square minus xy minus yz minus xz minus x into y minus y into z minus x into z. In fact, this is x and this is z. All right. Is this fine, children? Simply expanding using the identity. Is that fine?
Yes, ma'am.
Yeah. Once you write this, that's all, children, you're done. So use the identity and write this. And then it's only about simplification. So open the bracket here. Open the bracket here. So you will get a plus b plus b plus c plus c plus a. When you open the bracket, you will get a plus b plus b plus c plus c plus a. So what is that? So it will be 2a plus 2b plus 2c. So that I've written straight away. 2a plus 2b plus 2c. When you open the bracket here, you will get a plus b plus c plus c plus a. So that means it's 2a plus 2b plus 2c. So I've written that directly here. And then expand all this. A plus b the whole square, b plus c the whole square, c plus a the whole square. Expand all that. This is a plus b the whole square. This is b plus c the whole square. This is c plus a the whole square. Then here multiplying. All right, that's the next step. And then open the bracket. Next step, open the bracket and simplify. That's all. Once you just use the identity and expand, that's all. Then it's only about simplification. Then remove the brackets, and you'll have to simplify the like terms. There's one a square here, one a square here, and minus a square here. So you will be left with only one a square. So you can do that simplification. Do that, and this is what you will get. A plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. All this one simplifies to this. And what is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca? It's a cube plus b cube plus c cube minus 3abc. This product is nothing but a cubed plus b cube plus c cube minus 3abc. That is only a plus b plus c into a square plus b square c plus c square minus ab minus bc minus ca. That's it. That's the RHS. Yes, children, please write down. This is the identity used here. Done, children?
1 minute, mom.
Yeah,
Right.
okay. No hurry. Yeah.
Completed, ma'am.
All right. So here the left-hand side, this one, the LHS is exactly of the form x cubed plus y cubed plus z cubed minus 3xyz. So we just expand it using the identity. We know that it is equal to x plus y plus z. This is x, y, z. X square, y square, z square. Xy, yz, zx. That's all. We just expand using the identity, and then it's only simplification after this. Once you write this, what are we doing next? Open the bracket. A plus b, b plus c, c plus a. So you'll get 2a, 2b, and 2c. And then here a plus b the whole square, expand 3 terms. B plus c the whole square, expand 3 terms. C plus a the whole square, expand 3 terms. Then here you'll have to multiply a into b, ab, a into c, ac, b into b, b square, b into c, bc. That's what is happening here. This minus sign as it is outside. We multiply the binomials. 2 terms and 2 terms, you'll get 4 terms. Similarly, put the minus sign as it is. B into c, bc. B into A, BA, C into C, C squared, C into A, CA, like that. That's the next step. And then expand, meaning remove the brackets here, not expand, remove the brackets here. So it looks like this, it looks like this. Then it's only simplification, simplify the like terms. So you'll be left with only these terms. And now we know that a plus b plus c into a square plus b square plus c square minus ab minus bc minus c is nothing but a cubed plus b cubed plus c cubed minus 3abc. This 2 which is already there. This is the RHS. This is the right hand side. So we started with the LHS and we arrived at the RHS. Hence proved. Done, children?
Yes, ma'am.
All right. Yeah. Yes, children. Please write the question. Please write down, then I'll explain.
Completed, ma'am.
Yeah. All of you?
1 minute, ma'am. 1 minute, ma'am.
Yeah, yeah, all right.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah, children. Fine. So this again is the the direct application of an identity to find the value of this expression. To find the value of this expression, we have to use this conditional identity. That is when x plus y plus z is 0. When x plus y plus z is 0, then x cube plus y cube plus z cube is equal to 3xyz. This part, sorry. Okay, so we have to use a conditional identity that when x cubed, when x plus y plus z is 0, x plus y plus z is 0, then x cubed plus y cubed plus z cubed is equal to 3xyz, is equal to 3xyz. Okay. So you can see here there's something like x cubed, y cubed, and z cubed. Okay. I think it's better we write it as we all wrote down, no? Not wrong, but since there's already x in a here, we can say p cubed. We can say p cubed plus q cubed plus r cubed is equal to 3pqr. If p plus q plus r is 0, p plus q plus r is 0, because we already have x and a here. Okay, nothing wrong, but it's better to write this. I didn't notice by mistake. It's not wrong, children, but what I'm saying is since the expression already has x and ABC in it, you should use a different, you must use different letters when you write the identity. So like p cube plus q cube plus r cubed is equal to 3pqr if p plus q plus r is 0. Fine, just make this correction alone. Now let's find. Now this is our p, this is our p cubed, this is our q cubed, this is our r cubed. All right. So this is p cubed. So this is p. X minus a is p. X minus b is q. X minus c is r. So what is p plus q plus r? When you add p plus q plus r, you get 3x minus abc. 3x minus you can take common of a plus b plus c. But it's given that a plus b plus c is equal to 3x. It's given that a plus b plus c is equal to 3x. So that means 3x minus 3x. That means 3x minus 3x, which is 0. Which is 0. I'll just repeat. First thing I told you is just change this to PQR. PQR. PQR, because in the given expression, we already have the letters X, A, B, and C. So write the identity using different letters, which are not present in the expression given. Now, this is the conditional identity. So we'll have to find P plus Q plus R. What is P plus Q plus R? This is P. This is only P. This one is Q. And this one is R. See here, P cubed plus Q cubed plus R cubed. So which one is P? P is X minus A. P is X minus A. And Q is X minus B. And R is X minus C. So let's find P plus Q plus R. Let's find P plus Q plus R. So when you add P, Q, and R, what do you get? 3x minus a minus b minus c. Take out minus common. So you get a plus b plus c in the bracket. But it's given that a plus b plus c is equal to 3x. So 3x minus 3x, which is 0. So this is the answer we got. P plus q plus r is 0. Then what is p cubed plus q cubed plus r cubed? It's equal to 3pqr. 3pqr. Because p plus q plus r is 0, p cube plus q cube plus r cube is equal to 3pqr. So 3pqr. Here we have worked p plus q plus r and we got 0. So that means this p cube plus q cube plus r cube is equal to 3pqr. 3pqr. Now take up the whole expression. Now take up the entire. We have now only evaluated this part is 3x minus a into x minus b into x minus c. We have evaluated only this part. Now take the full thing. We have to find the value of the full thing. Now take the full thing. This is the given expression till here. And we found the answer for this. The answer for this one is 3 into x minus a into x minus b into x minus c. And what you have here is also 3 into x minus a into x minus b into x minus c. So they just get cancelled and the result is 0. And the result is 0. You can also do this in a different way. I'll show you. So this is using the identity, using the conditional identity. This is the given expression. This is the given expression. We just found the value of this one. We just found the value of this one is 3 into x minus a into x minus b into x minus c. And this we write as it is. They're the same, so they get cancelled and the answer is 0. The other way of doing this is, all of you finished writing this?
Yes, ma'am.
Yes, ma'am.
Yeah, all of you please make this correction. Make this P, Q, R, P, Q, R and P, Q, R here. All of you make that correction. All right, you can do it like this, or you can use the identity, P cubed plus Q cubed plus R cubed minus 3pqr is equal to P plus Q plus R into P square plus Q square plus R square minus PQ minus QR minus PR or RP, whatever. All right, we can use this identity. Now, what is here? What is P? P is x minus A. And what is Q? X minus B. And what is R? And what is R? X minus C. X minus C. You can see there. X minus A, X minus B, X minus C. P, Q, and R. X minus A, X minus B, X minus C. Write it again, children. Please relate it. I'm first writing the identity. You can see here there's something like P cubed here. See here, there's something like this is P cubed, Q cubed, R cubed, 3pqr. So the given expression is exactly like P cubed plus Q cubed plus R cubed minus 3pqr. It's exactly like this. And the answer which we are going to write for this is P plus Q plus R into P squared plus Q squared plus R squared minus PQ minus QR minus PR. This is what we're going to write. So wherein our P is X minus A, Q is X minus B, and R is X minus C. Now let's write. This is P cubed. This is a question, children. You basically have to write the question again. We'll have to find the value, right, of whatever is given. So that is equal to, that's equal to the question P cube plus Q cube plus R cube minus 3xyz is equal to P plus Q plus R. So in the first bracket, P. This is P. Oh, sorry. What is P, children? Write the answer. See, the question is PQ plus QQ plus R cube minus 3PQ. Write the answer. P plus Q plus R. What is P? This one. Plus Q. This one. Plus R. This one. P plus Q plus R into P square plus Q square plus R square. P square plus Q square plus R square minus PQ minus this is P and this is Q minus QR. So this is Q. This is R minus PR. This is P and this is R. Close the bracket. We've used identity. Now write the second bracket as it is, children. Okay, the second bracket will come as it is. In the first bracket, what you do, you open the bracket. So you'll get x minus a plus x minus b plus x minus c. First one, the first part, open the bracket. The second one will come as it is. Don't do anything. Don't expand. Don't do anything there. Don't expand. Don't simplify the second part at all. Now here you will get 3x minus a minus b minus c. Write the second bracket as it is, children. Write the second bracket as it is. Now here this is equal to 3x. You can take out minus common here. Minus common here. Or you can also do this, children. You can also do this. If you want, you can take minus common, or you can also do this. What is 3x? What is 3x, children? In the question given, what is 3x?
A plus B plus C, ma'am.
Yeah, so instead of 3x, you can write a plus b plus c, and that minus a minus b minus c as it is. So a minus a, b minus c minus c gets cancelled. So 0 into the second bracket, which is 0. 0 into the second bracket, which is 0. This is one way of working. 0 into the second bracket is 0. So the value of the given expression is 0. Or what you can do is you can take out that minus common. See here. Or what you can do is you can write 3x here and take a minus common, a plus b plus c in the bracket like this. Because when you take a minus common in the bracket, it will be a plus b plus c. Then the second bracket as it is. So that's equal to, let me write it here. That's equal to, yeah, that's equal to 3x minus 3x, because a plus b plus c is 3x into the second bracket. So 3x minus 3x is 0, and 0 into the second bracket is 0. So the value of the given expression is 0. So that substitution, you can do anything. Instead of 3x, you can write a plus b plus c. Or instead of a plus b plus c, you can write 3x. So you can decide which one to do. Is it understood, children?
Yes, ma'am.
Yeah, please write down.
Yes,
Yes, children, please write down. Is equal to 0. The value of the given expression is 0. All right, children, since
Completed,
it's
ma'am.
all right, very good. Very good, children. If you have completed, fine. If you're still, in the beginning of the answer, please take a screenshot, children.
Taken, ma'am.
All right, please complete the answer. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you, ma'am.
Thank you, children.